Okay, we're going to do some data analysis now that I want to just show you some cool stuff you can do with Polyfit and Polyval. Okay, so I made some projectile data and then I noised it up. Basically, I made a, your cannon fires. So in theory, maybe you've seen this kind of a problem before. So you have an initial velocity. So your velocity in the x direction would be v naught times cosine theta, and that's going to give you your x direction. Your initial velocity in the y direction would be velocity times sine theta, and then you run it through, and g is negative 9.81 meters per second squared if you're in meters per second. And projectile motion, you get this parabola. So if you really have never seen the physics before, that's fine. For the purposes of today, just smile and nod and know that, yes, you have a t squared and a t, so that means you've got a parabola for the vertical motion, and you have a linear for horizontal motion. And when you put, when they're with respect to t, when you put them together, you get a projectile motion as a parabola. Okay, that was fun. So I've made some fake projectile data, so the idea would be that I measure this data, but because I'm measuring it, it's not perfect. So I'm going to load this projectile data. So I have the time that I measured it and the x and the y position. So if I plot x and y, I'll get something of value, maybe, eventually. Here we go. Okay, so that's my x and y data. It looks parabola-like, so this is the x position and this is the y position. So I have x and y. I'll plot that. I could also plot, why is it over there? I want it to be maybe here. I'll just keep it there. Off to the side so you can see it better. So I'm going to plot x and y. I'll go ahead and I'll plot x and t, or so t goes across, t is the independent variable, x is the dependent variable. So as time passes, it moves away from you. Duh. As time passes, it moves away from you, and it gets to a position of about 70 at about 2.5 seconds. Did that match what we saw before? Like, we can't see seconds here, but it got to a position of 70 in the x direction. It looks like it got to a max of about 8.5. So if I do, there's the y. The y is also parabola, so again, in 2.6 seconds, it got to about an 8.5. So that's your parabola thingy. Okay, so we know it should look like a parabola. So what we're going to do is something called Polyval. So Polyval means basically help Polyval, and this evaluates the polynomial. I'm using them in the wrong order. Before you polyval, you have to polyfit. Help polyfit. So I'm going to polyfit it, and basically the way polyfit works is I say, okay, well, I want to give you my x and my y values, and it's going to be an nth polynomial. So like, so p equals polyfit x, y, and then for a parabola, that's a second degree polynomial. So, so t squared, since it has a t squared in it, a parabola is a second degree polynomial. I'm not going to say t squared because that's not exactly what I'm doing. I'm not doing this with respect to t. I'm actually doing it with respect to x and y. Okay, so what this is giving me is, and I want to make sure I've got this right, is, let me show you for sure. I'm going to hit the documentation just to be super happy about it and see if it gives me some good examples. No, it's not giving me what I want. So basically, I'll just show you the answer. So it's giving me this. So basically, it means that there's a function called f of x. So y equals f of x. I'm going to move this over in a second. Y equals f of x, where y equals, and I think they do this in increasing order. Let me try it again. Help Polyfit. I'm pretty sure in a least squared sense for the data. Returns the coefficients of degree of n, and I think it does the, we'll find out. I think it goes like, this is the 0th term. Hold on, let me run this again. So I think this is the 0th term. So I'm just going to copy this. The 0th term plus, you know, x to the 0, plus this times x plus this times x squared. Okay, so I'm just going to make this little function. Okay. Okay, come here. So I'm just going to make a fake function over here. I know I don't have to save it off by itself. I just want to because it makes me feel good. Come here. Can I save this, please? Okay, so save. 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 Okay, so f is there. So basically the idea is if I want to say new y's is going to be f of x. If I plot this, oh, are you going to be a toot? Oh, I forgot to put the dot there. Silly. There's the, that's not exactly what I want it to be. Maybe I have them in the wrong order. Let's try and do the other order. Maybe I have them backwards. So maybe this is the times x dot squared and the times x and the plus 0, like that. We'll see if that works that out better. Oh, there you go. Okay, so here's what I'm going to do. So it turns out that these polynomials, so I'm going to say, I'm going to make this as a note to myself because I totally didn't know. So the polynomial coefficients are in the order x squared, x to the first, and then x to the 0. Okay, because it's to the 2th power, so the 2nd power. Okay, so so I copied those and I put them over here. I should have known it was negative because that's how you get a negative facing parabola. I'm just not paying attention. Okay, so I'm going to plot that guy as my actual line, and then I'm going to plot the old values as just like spots so you can see where they are. So, okay, so you see that? Isn't that neat? So basically it is a parabola, sort of, but you can see kind of how much error there is. And that's not super surprising because I know how much error I gave it. I gave it a pretty chunky error. But it still did estimate it as being a parabola. So polyfit, you know, if I, for example, tried to polyfit this to a cubic, it's going to come up with something super stupid. Now, obviously, me writing this f of x function is a terrible idea, and this isn't what I really want to do in real life. So actually, there's a way to do this, which is called Polyval. So I think I can do it this way. New y's equals Polyval of my x. Let me see if that works. No, how do I do Polyval? Help, Polyval, and Polyval. Oh, I have to give it the p. I have to give it the coefficients or it doesn't know what it's doing. There we go. Okay, so that gives me the exact same picture, actually. So hold on. I'm going to do, hold on. I'm going to do them both, just so we know I'm not crazy. I'm going to do these in green, and I'm going to do this in blue. It's the exact same thing. Pause, green, blue. See, the exact same picture. Okay, so I am now convinced that using Polyval will give me the same thing as using my plot thingy here. And that's pretty cool because, first of all, I'm able to confirm that that's what I want it to be. Second of all, I can, confirm that physics is right. Now, just for funsies, I thought it would be neat to see if we could estimate what we thought the beginning of the velocity and the acceleration is. So, first of all, we're going to plot y and t as a parabola, and it should give me something like this. So, I'll do this kind of in its own little section. I'm just going to reload the projection data, and now, so I'm going to do the polyfit on the y data. So polyfit y, we'll call it polyfit y. So the t is the guy that's going to go left and right, and the y is going to go up, and it's going to go like that. Okay, so looking at this, this means that it's negative 4.6 t squared plus this t plus almost 0. Okay, now if I look at my function, so the v, this is in a different order, but the coefficient in front of the t squared is supposed to be negative 1/2 g. Now, if you know stuff about math, that negative 1/2 g is supposed to be 9.81. So let's see how close we got. So our g estimate would be that py at 1, and we want to multiply it by negative 2, because instead of multiplying by negative 1/2, we're going to flip it back. And so it's 9.3. So it's not exactly 9.801, but it's 9.801, but it's 9.3, so that's pretty close. So that's our estimate for, if we were running this as, say, an experiment, I could say, well, my estimate for the acceleration due to gravity is 9.81, or negative 9.81 meters per second. And then my v naught in the y direction is going to be given by the coefficient that is in front of the t, right? So that coefficient that's in front of the t. So the coefficient in front of the t is the second term. So py second term. Okay, so now I'm going to polyfit the x as well. But this is different because when I polyfit the x is actually just a linear. There's no t squared here. If I try to t squared it, I'm guessing it's going to come out pretty close to 0, and it does. But I'm going to go ahead and tell it, it's just a linear equation. Does that make sense? So I'm telling it it's a linear equation, not a squared equation. And so if it's a squared equation, a linear equation, then the coefficient in front of the t is v naught x. V naught x is py, or px, can't spell, in the first position. So there we go for that. Padoop and padoop. Okay, so I have my estimate for gravity, I have my v naught in the y, and my v naught in the x. Now, if you happen to remember anything about vectors, you know that the resultant is the square root of v naught. And you're like, I didn't know I had to remember stuff. Yeah, v naught y squared plus v naught, if you like them in order, v naught x squared plus v naught y squared, right? And the angle, if we're assuming we're measuring off of the positive x-axis in a counterclockwise direction, is the arc tangent, I'm going to say in degrees, from v naught y divided by v naught x. Okay, so what this is saying is, based on these calculations, our estimate is that whenever I originally created this data, I used 9.3 for gravity, which is obviously not true. I used 9.81, but the initial velocity was about 29.7, and the angle was about 24. So let's go see. So initial velocity was 30, which is what I had here, and my initial angle was 25, and I guessed that it was 24. So that's pretty good, especially considering, what was the length of T? You know, we only had 14 data points to choose from. So considering we only had 14 data points, that's a pretty good fit. And so that's what I think is a pretty neat little thing that you can do with Polyfit, is you can mess around with, you know, putting in some extra data and kind of working backwards. And if you know things about whatever it is you're looking at, you know, this is a useful little tool to be able to have.